Hello students, today we will continue our discussion on the chapter sets. In this video, we will discuss about the topic Venn diagrams and operator of sets such as union of sets and intersection of sets. Let us start with the topic Venn diagram. Most of the relationships between sets can be represented by means of diagrams which are known as Venn diagram. You can look at this figure. These all figures in the slides can be considered as Venn diagram. Okay, these all figures are Venn diagram. Okay, by this Venn diagram you can represent the relationship between two or more than two sets. Okay, about the relationship of universal set and subset. Okay, Venn diagram are named after the English logician John Venn. These diagrams consist of rectangle and closed curved, usually circle. As you can see in this figure, here is a rectangle and three circles. Okay, the universal set is represented by rectangle and the subsets are represented by circles. This rectangle represent universal set. Okay, and each of these circle representing subsets of this universal set. In Venn diagram, the elements of the sets are written in their respective circle. So, if I zoom this figure, you can say that for this circle, the element is C, Y, Q, Z. For the second circle, the element is A, Y, Q, X. And for the third circle, the element is B, Z, Q, X. Okay. Now, in figure 1, if you look at this figure 1, universal set is the collection of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Where A is a subset of this universal set and A contains 2, 4, 6, 8 and 10. Look at here. This rectangle 1 is the universal set containing the element from 1 to 10. All this element 1, 2, 3, 4, 5, 6 all belongs to universal set. Where this circle represent the subset A which contains 2, 4, 6, 8 and 10. Okay. This diagram is called Venn diagram and this Venn diagram represents the universal set which contains a subset A, okay, and A contains 2, 4, 6, 8, 10. Right. Now if you look at the second diagram, here again the rectangle represent universal set. That means all the elements between this rectangle is the element of the universal set. So you can say universal set contain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Where there is two circle. Circle B contains the element 4 and 6. Where circle A contains all the element inside this circle. Set A contains all the element inside this circle. Set A contains all the elements inside the circle. So A contains 2, 4, 6, 8 and 10. So I told you A contains 2, 4, 6, 8, 10. B contains only 4 and 6. So you can say that B will be a proper subset of A. look at the diagram. This B is inside the circle A. So by this diagram you can represent that B is a subset of A set. Okay, that's why B circle is inside the A circle. And both this A and B will be inside the universal rectangle. Okay, all these things is given in this slide. Now next we will discuss about the operator of sets and the Venn diagram related to that operation. Union of set means let A and B are any two set. The union of A and B is the set which contains all element of A and all element of B, the common element being taken only once. The symbol, this one, is used to denote union. Symbolically we write A union B and usually read as A union B. Okay, that means this symbol represents the union of two set A and B. And what does it mean by union? Union is the collection of all the elements of A as well as B. Okay, so we will discuss about the example. Suppose A is the collection of the element 2, 4, 6, 8. B is the collection of 6, 8, 10, 12. Okay, look at the diagram. This A circle represent A set which contains 2, 4, 6 and 8. Okay, and B is another circle. This second one is another circle representing B set and contains 6, 8, 10, 12. Now A union B will be the collection of all elements of A and B both. So the collection will be 2, 4, 6, 8, again 6, 8, 10, 12. Now this 6, 8 and 6, 8 is common for both the sets, and A union B will be another set. I told you in set one element cannot repeat twice. Okay, that's why you will write 6, 8 only once. So the correction will be 2, 4, 6, 8, 10, 12 because this 6, 8 is already here. Okay, so union B is 2, 4, 6, 8, 10, 12. And when you are representing this in Venn diagram, A is this set, this circle, B is this circle. Since 6 and 8 both are common for both set, look at here, this 6 and 8 is in this intersection part, in this common part, right? 6 and 8 is in this common part. So that you can say 6 and 8 is the part of first circle as well as second circle. Okay, so this whole blue region is the diagram of A union B. Now next example, suppose A is A, E, I, O, U, B is equal to A, I, U. Show that A union B is equal to A. Obviously if you do the union of these two sets, it will be the collection of A set as well as B set, collection of the elements of A as well as B. So it will be the collection of A, E, I, O, U, because here the elements of B sets is already inside the A. Okay, so as you can see, the union will be the whole A set. This example states that union of sets A and its subset B is the set A itself. Okay, here B is subset of A because all the elements from here belongs to here. And if you do the union of A union B, it will be equal to the bigger set. Okay, it will be equal to the bigger set. That means suppose this one is A set and this one is B set. B is subset of A. The union of A and B will be the whole A set. Okay. Similarly, next example, X is Ram, Geeta, Akbar. Y is Geeta, David, Ashok. So union B will be, what will be union B? It will be Ram, Geeta, Akbar, David, Ashok, because Geeta is common. Ram, Geeta, Akbar, David, Ashok. Okay, this X union Y contains these 5 elements. Now some properties of the operation of union, you have to remember these 5 formulas. That is, union is commutative, A union B and B union A both is same. They are associative. If you do the union with phi, okay, if you do the union of a set, of a non-empty set to a null set, it will equal to the set itself. Okay, this is the third point. If you do the union of A itself, A with A itself, it will be equal to A, and universal set union A is equal to universal set. Okay, just try to remember these 5 formulas. Now intersection of set, this is another operation. Intersection of set. The intersection of two sets A and B is the set of all those elements which belongs to A and B, which belongs to both A and B. That means the common element from A and B, the collection of common element from A and B is considered as A intersection B. The intersection sign is this one. Okay, this one is intersection sign. Okay, so when you are when you are operating intersection, suppose you are applying intersection on two sets C and D, you will denote it by C intersection D. Okay. Now example, suppose A is the collection of 2, 4, 6, 8. B is the collection of 6, 8, 10, 12. This is the same as previous example. Here the common part is 6, 8. 6, 8 are common in both A and B. That's why A intersection B will be the collection of 6 and 8. Okay. By Venn diagram, suppose this is A, this is B. First circle represent A and second circle represent B. As you can see in the figure, this orange portion is common for both the circle. So this orange portion is considered as A intersection B. So this is the proper Venn diagram for intersection A intersection B. Now next example, X is Ram, Geeta, Akbar. Y is Geeta, David, Ashok. What will be X intersection Y? So in between X and Y, which element is common? Geeta. Right, Geeta is common in both the set. That's why X intersection Y will be collection of one element Geeta. Again, A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. B is equal to 2, 3, 5, 7. What will be the intersection? Look at here, 2 is common, 3 is common, 5 is common, 7 is common. So if you apply A intersection B, it will be collection of 2, 3, 5 and 7. And this set 2, 3, 5, 7 is same as B set. So you can write A intersection B is equal to B set. That means if B is subset of A, if B is subset of A intersection B will be the smaller set, and A union B will be the bigger set. Look at here, this is A, the bigger one, this is the smaller one, B. If you do the union, this will be the collection of all the elements, that's why it will be A. Okay, and if you do the intersection, it will be the common part, which is equal to B. Okay, now disjoint set. If A and B are two sets such that A intersection B is equal to 5, then A and B are called disjoint set. That means if there is two sets which does not have any common element. If two sets does not have any common element, then that two sets are considered as disjoint set. For example, suppose A is the collection of 2, 4, 6, 8. B is the collection of 1, 3, 5, 7. Between A and B nothing is common, that's why here A and B will be disjoint set. And disjoint set is represented by this Venn diagram. Look at here, this is A set, this is B set, and there is nothing common between these two circles. These two are disjoint circle representing disjoint set. Again, some properties of operation of intersection is given. You have to remember this 5 formula. They are commutative, associative. Now phi intersection A will be phi, universal set intersection A will be A intersection A will be A, and this is distributive law. Just try to remember these 5 formulas. Now here the various kind of Venn diagrams are given. Look at here, in the first diagram, this is the shaded portion. Okay, if you look at the blue shaded portion, this is the collection of all the elements of B as well as C. So the first one is the diagram of B union C, the Venn diagram of B union C. Now if you look at the second figure, means this one, the blue shaded portion is the common part of A and B, right? Look at the figure, the blue shaded portion is the common part of the circle representing A and B sets. So for common, you are using the operator intersection. That's why this is the diagram of A intersection B. This is the diagram of A intersection B union C. Why? Let me explain it. First of all, when you are doing B union C is this whole orange portion. Okay, so B union C is whole this orange portion. Okay, and A set is this one, right? So the common between A and B union C, the common between A and B union C is equal to this part. Okay, this is common, this is the part of A as well as B union C. So that's why you will write A intersection B union C will be the blue part. Okay, clear? Now for the fourth diagram, as you can see, this blue shaded portion is the common part of A and C. That's why it is the representation of A intersection C. And the fifth one, this is the representation of A intersection B union A intersection C. Why? Again, first of all, do A intersection B. This is A set, this is B set. The common part between them is this section, the pink one. Okay, again, this is A and this one is C. The common part between them will be this orange portion, right? Now if you A intersection B is the green one. Okay, and A intersection C is the orange one. Okay, so if you apply the union operator between them, okay, if you apply union operator between them, this will be the collection of pink as well as orange. This is the collection of these two regions. So that's why this blue shaded region represent A union B, A intersection B union A intersection C. In this way you have to represent Venn diagram. So this is all for today. Thank you.